Okay, and we're back for part 3 about the ambiguous case. All right, so you remember from the video that you watched like 2 minutes ago or a minute ago or something like that, that the ambiguous case means that we're either going to have 0 triangles, 1 triangle, or 2 triangles, depending upon circumstances. So here's our situation. Again, I kind of drew this all for you, just like we did on the board. And so it says, can a triangle be formed with A equals 15, B equals 25, that's B right there, 25, and so B is over here somewhere maybe, and angle A is 85 degrees. So what we want to do first, of course, is find the altitude, or the height of the triangle, and then we can figure it out from there. So we're going to figure out the altitude of the triangle right here. So this guy right here, and that's easy to find. All we need to do is, well, this height right here is going to be based on the angle and the hypotenuse there. So we're going to do sine opposite over hypotenuse. So we're going to do sine of 85 equals h. Sine of 85 equals h over 25. And so in order to find h, we just do sine of 85 times 25. So 25 times sine of 85 equals 24.9. Yeah, 24.9. So we know that h equals 24.9. So in order to form a triangle, we got to be at least 24.9 for the value of a. So let's take a look at the value of a here, 15. So because 15 is shorter than the height, we're going to have Tyrannosaurus rex. So we're going to have no triangle here. T-Rex arms, no triangle here. So the answer is nope. We cannot form a triangle with this stuff. Okay, let's jump over to another situation. Okay, so we're going to find the missing parts of this triangle here. And so, again, this is going to be another ambiguous case situation. And, yeah. Okay, so we need to draw our triangle here. So I'm going to recommend, actually, that we put C at the top. Yeah, let's put C at the top. All right, so here we have our situation right here. So here's A, and across from A is 12. B is going to be over here somewhere. We don't know exactly where, but we know that this will be 5 then, because B is over here. And we know that A is 31, so we got our little dotted line situation right here. And we know we got 31 degrees. Okay, so we need to find all the missing parts. So first of all, we need to find out whether we have any triangles at all. We need to do the altitude test. So we're going to do the sine of 31 times 5, and that'll tell us the height there. So sine of 31 times 5. So 5 times the sine of 31 equals, and we got 2.58. And it says here that A is 12, and that's clearly longer than 2.58, so we know we have at least one triangle. Okay, so A is 12, actually, because we now see that that's 12, and that's going to be more than twice that length, so we know that we're going to be over here somewhere. So it's going to be our 12 right there, and clearly, again, that was longer than the altitude that was right there. Okay, so we need to figure out the rest of the stuff here. So we need to figure out A is 31, find the missing parts. I feel like we're missing something here in this diagram. 5, 12, 31. I was going to say it's 5, 12, 13, but we don't know that. I left out a piece of information from this problem. That's not very comfortable. Okay, oh no I didn't. I can find this angle right here. So I need to find this angle right here because I have an angle and I have an opposite side. I have an opposite side, so I can find the angle right here. So we're going to call this one B. This is angle B right here, of course. So we got 5 over the sine of B, which we don't know, equals 12 over the sine of 31. All right, so we need to find the sine of 31. So sine of 31 equals 0.515. So we got 5 over sine of b equals 12 over 0.515. 0.515. So if we want to find this, we're going to cross multiply and divide. So we're going to do 5 times that divided by that. So times 5 equals, divided by 12 equals, and we find out that the sine of b is 0.2146. So sine of b equals 0.2146. Well, finding out the sine of b isn't very helpful. We need to actually know what b is, so we just do the arc sine of that. So we do second sine of 0.2146 equals, and that's 12.39 degrees. So we got 12.39 degrees. So that's that angle right there. And we have that side. So now we can figure out this angle up here, because we're going to add this to this and subtract from 180. So we got 3143.39. So 180 minus 43.39 equals 136.61. So this angle right up here is 136.61 degrees. So that's a missing angle. Here's a missing angle. And we got one missing side to work with, and that's this one right here. So we just set it all up again. So we do, this is going to be C right down here. So we're going to have C over sine of 136.61 equals, and let's work with the stuff that we already had here. We had this and this already. So we're going to do 12 over sine of 31, which we found out already to be 0.515. And we calculate that, we cross multiply, we divide, and boom, we have C, and that means we're done with that. So I'm running out of room right here, that's why I didn't do that. So we're going to move on to the last part of this question here. So what we want to know is it possible that there is another triangle that we could have formed with this information right here? Well, again, thinking about that ambiguous case demonstration that I did with the string, we see that we did the altitude test already. And so I don't remember what that came out to be. It was like 2.5 or something like that. And so so we see that 12 was longer than 2.5. So we knew we found at least, or we could find at least one triangle. But the question is, could we find another triangle? Well, if this length right here happened to be between 2.5 and 5, then we'd be able to form two triangles. But so that way it would swing back and forth between here and here, right? We'd have two triangles that we could form, one over here and one over here. But that's not the case. 12 is bigger than 5, so this only has one possible solution, because the side here, 12, was bigger than the altitude and smaller than that given side. So we're going to move on to, so the answer here is another triangle possible? No, there is not. As you can imagine, in this case, there's going to be two triangles. All right, so here's the deal. So we're going to set up our diagram again, and so I'm going to recommend that we do the same format so we don't get lost here. So we're just going to have this unknown side over here. We don't know what this side's going to be, but we do know that angle A is 58 degrees. We know that. And we know side B is 5. And we have A is 4.5. So what we don't know is where is this going to land over here, and how many places is it going to land. So again, we're going to do our little altitude trick right here. So we're going to find out, well, what's the altitude, and is this going to be long enough? Are we even going to have any triangles at all? So again, we're going to do 5 times the sine of, 5 times the sine of 58. That'll tell us the altitude. So 5 times the sine of 58 equals, and that's 4.24. Okay, so we got 4.24 right here, and as it turns out, this side is 4.5, So it's bigger than the altitude, smaller than this guy right here. That means we're going to have two triangles, right? So if it's bigger than the altitude and smaller than this side right here, we're going to have two triangles. So we need to find both triangles. So we did the altitude test to determine the number of triangles, and we figured out that there were two triangles. All right, so we're going to have to find out all the information for both triangles. Yeah, so we just need to set up our situation here. So we're going to make believe that our first triangle is over here. And as you can imagine, we're going to have one triangle over here with an acute angle, and we're going to have another triangle over here, and that angle is going to be obtuse. We'll have both of those. We'll work with the acute one first. So we're going to set up our situation right here. So we need to find this angle right here, just like we did in the previous example. Nope, we're missing a side here. Oh, side A is 4.5. There we go, 4.5. That goes right there. So we need to find this angle right here. And this angle, as we had before, this was A here, this is C here, this is B down here. So we're going to have 4.5 over sine of 58 equals 5 over sine of B. And so we find our stuff here. So we got sine of 58. So sine of 58 equals 0.8480. So 4.5 over 0.848 equals 5 over sine B. So again, we're going to cross multiply and divide. So we multiply here, divide there. So times 5 equals, divide by 4.5 equals, and we have 0.9423. So sine B equals 0.9423. And then we do the arc sine of that. So arc sine of 0.9423 equals 70.44 degrees. So B equals 70.4, we'll just do one decimal place, 70.4 degrees. So that goes right in there, 70.4 degrees. Okay, so we have two angles. We need now to find the third. That'll be right over here. So 70.4 and 58 is 128.4. And so we need now 51.6 degrees to get to 180. 51.6 degrees. I think that's right. 128.4 and 51. Yeah, that's good. So we got our two angles. Now we just need to find this missing side over here, side C. So let's do that right over here. So we'll work with two things that we already know again. These two guys right here. So 4.5 over sine of 58. So 4.5 over sine of 58, which we already figured out to be 0.848 equals. And then we have the missing stuff right here. So we need to find side C, which we don't know. That's going to be side C. And we do know the angle is 51.6 degrees. So we need the sine of 51.6. Okay, so a common error here, I will tell you, is to write just 51.6 right here and forget to write sine, and then cross multiply and divide and get some weird answer up here. So please make sure you're doing the sine of 51.6. And again, I'm sure we can all figure out the sine of 51.6, multiply by that, divide by that, and get C, and boom, we're done with that. Okay, so that is so C equals whatever it equals, and we then have our triangle solved, right? We got all three sides, 1, 2, third side here. We got all three angles, 1, 2, 3 angles there. So we got all the stuff we need. So that's case 1, where we have an acute angle for B. Now we also have an obtuse angle for B. And so, so we have this right here. Sine of B is 0.9423. We're going to do the rest of this problem on the other side of the page. So sine of B equals 0.9423. That's important. So sine of B equals 0.9423, which turned out to be how many degrees? 70.4. So that was 70.4 degrees. We're going to use that in just a moment. And we're going to have our same diagram here. So we got 5, 4.5, 58. So we got 5, 58 degrees. And we'll make this right here. So the 58 is right in here on this angle. And so this is 4.5 right here. So what we need to do, again, is just find all the same stuff that we just did. So now we have an acute angle for this. So when we have the sine curve, of course, we know this from here. We have this right here. So we know that, we know that if we are, so there's 1, so 0.94, we're going to call right there because. So there I am at 70 degrees, but I got another one right over here. And again, because of symmetry, we are 70 degrees from here. We'll also be 70 degrees from here. So this is going to be 180 minus 70.4, or 109.6. So again, because of symmetry here, so because we have two cases, we have an acute angle, or sorry, an obtuse angle right here. We already did the acute angle case. That's right here, remember, because we're at 90 right here. Right, so, and we already figured out that this is 70.4 from 0 to here is 70.4. Because of symmetry, we're going to be 70.4 this way now from 180. So 180 minus 70.4 is 109.6. So right here we have 109.6 degrees. So we're going to set up our situation again. And so we got the sine of, let's do 4.5 over the sine of 58 equals, what are we missing right here? I already figured that out. So we need to find, this angle up here. So we got 109.6 plus 58. 109.6 plus 58 makes 167.6. 167.6. So that means we have 12.4 degrees right in here. So 12.4 degrees. So that's one of our angles that we found. 12.4 degrees. This is what we found right here. So now we're going to have this missing side right here, which is C. So we're going to have C over the sine of 12.4 degrees. And again, I'm confident at this point we can figure these two things out, cross multiply and solve, and we'll end up with C. So we get C equals whatever that happens to be. And now we have all three sides again, right? We got three angles, 1, 2, 3 angles, and we have three sides, 1, 2, and the third side right there. Okay, last problem. Trying to keep this under 20 minutes, I think. Yeah, good. So the last problem is an area problem. So as it turns out, if we have two sides and an included angle, then we can use this little formula right here. Area equals 1/2 AB sine C. So A and B are two sides, and C is the angle right in between them. And so we just plug the numbers into the formula, and it's really that easy. Okay. So you have a triangle plot of land where two of the sides are 90 yards and 50 yards, and the angle between them is 100 degrees. Find the area. So we have our situation right here. That's probably more than 100 degrees, but you get the idea. So this is 90. This is 50. This is 100 degrees. And we have a side over here. And we have, I'm going to color it in green because it's going to be a nice green lot right here. Nice grass and other plants. There it is. There's our lot. We want to find the area right there. So we just do our formula. So area equals 1/2 AB, so that's 90 times 50 times the sine of 100. So half of 90 is 45. So we got 45 times 50 times, oops, I should probably turn my calculator on. So we got 45 times 50 times the sine of 100. Sine of 100 equals 2215.82. 2215.82. Right, so I got 82, good. And this was in yards, yards, and yards. So this is yards squared. So there's the area. And that is all I have to say about that. So 20 minutes, 30 seconds, not too bad. So so we had 3 parts, 3 videos, and oh, that's just this video, isn't it? All right. So anyway, so there it is. There's the law of sines, and law cosines will come up next time. And I will see you guys on Tuesday. Be safe.